All right, so this next video is over pH. So you've seen this before in other classes. We've talked about it before. But pH is a scale based off of the logarithm of that hydrogen ion concentration that we talked about before. So if I know the concentration of my hydrogen ion, I can find my pH, right? Now, I'm going to use the logarithm function on my calculator, and you need to know that that would be in base 10, right? But otherwise, you should learn about that in trig, or should have learned about that in trig, right? We're just going to use the calculator, and hopefully you have a calculator with a log button on it. Otherwise, this doesn't work very well. So you might have to bring your own, because I don't have them, right? I only have 3 in the room that have a log button on them. So unless you want to go old school and use charts to try and look up values, you might want to bring a good calculator that has that logarithm function. Otherwise, you know that pH scale that goes from 0 to 14, you just now understand why it goes from 0 to 14 and why 7's right in the middle, because 7 was my exponent for my hydrogen ion when I was neutral, right? As long as there's the same amount of hydrogen ion and hydroxide ion, I'm neutral, and that's my exponent for that concentration there. Whereas 14 comes from when I combine those two. Remember, kW was 10 to the negative 7 times 10 to the negative 7, so you got a 10 to the negative 14th, right? 0 is just on the opposite end of the spectrum, right? And you should know that as I go from 0 to 14, right, when I'm on one side or the other of neutral, I either have an acidic solution or a basic solution. So if I have more hydrogen ion, that pushes me down to the acidic side. I get a lower number when it's all said and done. When I have a basic solution, I have more hydroxide than hydrogen, which actually means that I end up with a higher number, because not only is it a logarithm that's a base 10, right, using powers of 10, but I also have a negative log, right? Because I don't like negative numbers. People aren't comfortable with negative numbers, right? If it was from 0 to negative 14, this would make more sense in terms of context. But since people don't like negative numbers, we do a negative log of that hydrogen ion concentration, which is why low numbers are more acidic. That actually means there's more hydrogen ion, because low negative exponents means that there's more hydrogen ion than hydroxide. So when we were comparing those things to see if it was acidic or basic, same thing here, but now it kind of makes more sense, right? So you just had to accept that fact before, because you didn't even really know how to measure a concentration, let alone understand how there was more hydrogen ion versus that hydroxide ion. But now that we have this equation that says to take a negative log of that hydrogen ion, you can figure stuff out. So this slide here has a bunch of equations that I can use to go back and forth from one thing to the next, right? So to get a pH, you do a negative log of a hydroxide or hydrogen ion concentration, The inverse function of that is to take 10 raised to a negative pH power to get back to my hydrogen ion concentration. I already had my kW down here that I can multiply hydrogen and hydroxide to get that 10 to the negative 14th. But there's also this new function down here, right? I can take a pH and add a pOH to it to get 14, right? So all of these things are going to be useful when we go to do worksheets later. But initially, at least, what you're supposed to be doing, okay, if I have a hydrogen ion concentration right here, and I know this is my hydrogen ion concentration, because HCl is an acid, right? It's a strong acid. So I know what my concentration is here, so I do a negative log of 1 times 10 to the negative 10th. But again, just like before, if I have a 1, the math is easy, right? All a logarithm actually does is tell you what this power is on my 10. And then it's a negative log so that I can flip that power to make it positive. So as long as you have a 1 times 10 to the whatever power, your answer for your pH is just whatever that power is. It's a 10 in this case. Flip the sign, but my pH is 10 for number 1, right? Number 2, though, I actually have to use the calculator, because when I plug in the value for my hydrogen ion concentration, right, this is not exactly a 1. I'm also going to skip over number 2 right now because I forgot something, right? This is hydroxide technically, so I have to do something different, but I'll show you that in a second. Number 3 has hydrogen ion though, so let's do that one. Negative log of 1.23 times 10 to the negative 8th. Now again, you can get a pretty good estimate of what this pH should be, because it should be pretty close to 8, right? It's not going to be exactly 8. In fact, if I plug it into my calculator here, I'm going to get 7.91009, right? I'll learn how to round this in a second, but this is pretty close to 8. The only reason it's not exactly 8 is because this isn't exactly 1. It's not 1 times 10 to the negative 8th. It's 1.23 times 10 to the negative 8th. So if you have a hydrogen ion, that's what you do to get your pH. Do a negative log of your concentration for that hydrogen ion. Otherwise, if I was given hydroxide, I could turn it into hydrogen ion by using Kw and dividing. But there's actually a simpler route here. If I do a negative log of my 2.55 times 10 to the negative 3rd, that's not going to give me a pH, but it'll give me a POH. And there's a relationship between pH and POH, right? If I add those two things, I get 14. So what I actually end up doing here is I take 14 and I subtract my POH, which actually means that I'm going to add that log instead of subtracting, because 2 negatives always flips to a positive, right? So if I do this on my calculator, and it doesn't matter which one I do first, I can do the log of my 2.55 times 10 to the negative 3rd and then add 14 to it, or I could take 14 and add a log of 2.55 times 10 to the negative 3rd using parentheses, right? However you can punch that in your calculator should give you the answer. But again, this was a 3, right? Pretty close to a 3. So 14 minus a 3 would give me 11. So I know I can estimate this. It's going to be close to 11. But if I do this on my calculator, I'm going to get 11.40654, right? So it's really close to 11, just like I predicted. But if it's hydroxide, you have to add or subtract from 14, whatever your POH is. It's actually the simplest way to get there. So this last one is also hydroxide because I can see the hydroxide right here, right? This is the base that I'm giving you the concentration of. So I got to do the same thing. I'll do 14, and I'm going to add a log of 1 times 10 to the negative 3rd. But again, I should not need a calculator for this. Since I know that that log is just going to give me a negative 3, 14 plus a negative 3, or subtracting that pH that could be positive, whatever you want to think about it as, right? 14 minus 3 is going to be 11. So I know the value for my pH in all 4 cases. So I'm going to use these things to my advantage, right? What we just learned right there is that if I take 14 and I subtract my POH, I'm going to get a pH. You never want to have to do more work than you really need to do, because I could have in each of those cases taken 10 to the negative 14th, divided it by my hydroxide concentration, and then I would have gotten an answer that would be my hydrogen ion concentration. And then I could take that and put it into my pH equation and gotten my pH. But that takes more time. It's longer, right? So I don't typically choose to do that. I'm going to use whatever thing makes the most sense at the time that I'm doing it. So lots of different things that you can do, but these are my pH values for each of these. Last thing I need to understand is that I do have to round and I have to use sig figs for pH, but it's also weird. So you have to understand the numbers you're looking at. And you have to understand the fact that when I have this 6.13 times 10 to the negative 7th, that I have 3 sig figs in this number, 6.13. So I need 3 sig figs in my answer, but the hard part to understand is that really this 6 in front is just telling you how big or how small that number was. The number in front of the decimal is just going to be something close to this negative 7, right? So it doesn't actually have significance, right? If I wrote this in an expanded form, this number here, it'd be 0.1234560 zeros, 613. This number still has 3 sig figs, whether I have that 10 to the negative 7th or not. The 10 to the negative 7th just told me it's a really small number. And the log tells me how small it is, right? How many powers of 10 up or down, left or right, I need to move that decimal when it's all said and done. So this 6 does not have significance. It's just the 2, the 1, and the 3 that have significance when it's all said and done. So it's confusing. It's kind of weird. So when I look at these numbers up here, again, the 10 is just a 10. There's no significance in this number. It's only numbers after a decimal that would be significant. And I had 2 sig figs up here, so I need to add 2 zeros to this number. That may seem weird, but that's just the way that it works. Number 2, I had 3 sig figs in my number. The 3 is what ended up giving me that 11, right? So I don't worry about the 11 because that's in front of the decimal. I worry about getting 3 sig figs behind the decimal, which is why this is going to change into an 11.407, right? It's weird, but it is what it is. Again, 1.23 has 3 sig figs. The 7 is just telling me about this 8. So I need to look at 3 sig figs behind the decimal, and this is going to be a 7.910. And then finally, for my last one, 1 only has 1 sig fig, but that sig fig needs to go behind the decimal. So 11.0 would be an appropriate answer for 4. So again, that's kind of a lot to digest, but that's how you do your pH calculations with sig figs.